you by thesis123.com. I learn and teach online.
Here's the next question, number 44. The switches T1 and T2 in figure A are switched in a complementary fashion with sinusoidal pulse width modulation technique. The modulating voltage is Vm, this sinusoidal over here. Vm of t is equal to 0.8 sine 200 pi t volts, and the triangular carrier voltage Vc are shown in figure B. The carrier frequency is 5 kHz. The peak value of the 100 Hz component of the load current IL in ampere is. So, we are supposed to find out the peak value of the 100 Hz component of the load current. The load here is this inductor and the resistor connected over here. So, this is the load, and the values are 16 ohm and 12 ohm given at 100 Hz. Alright, so this is not a multiple choice question, so we will have to work it out and analyze the figures given to us. Alright, so let me just take another sheet of paper and note down as we go. So first we have our modulating voltage given to us, that's Vm of t is equal to 0.8 sine 200 pi t. Okay, so you should know that in this waveform given here, the sinusoidal wave is the modulating voltage waveform, and the triangular waveform is the carrier wave. So we have both, and the magnitude of the triangular wave is given to us as 1, and the magnitude of the modulating signal is given to us as 0.8. So the value over here right in front of the trigonometric function is the magnitude of the voltage, 0.8, or the peak voltage as such. This is our peak voltage of the modulating signal, and the peak voltage of the carrier waveform of the carrier signal is 1. So that's exactly what's given to us in the waveform here, that it is 1, the amplitude. Okay, so now the next step is to find out the modulating index. The modulating index M, and that's denoted as the ratio of the amplitude of the modulating signal Vm to the amplitude of the carrier signal Vc. Okay, this is the modulating voltage, this is the carrier voltage. So we have this as 0.8 divided by 1, which is 0.8. So we have the value of M, the modulating index, is 0.8. Now to find out the peak value of the load current, peak value of the load current, IL. So IL is Vmax divided by ZL. Now this is the total value of the load, the total impedance of the load, and Vmax corresponds to the 100 Hz component that is mentioned in the question. The question says the peak value of the current at the 100 Hz component. Okay, so we have to keep that in mind while solving. Now we don't know what Vmax is, so we need to find out what Vmax is. So Vmax is the peak voltage for the 100 Hz component, and Vmax is equal to the modulating index M multiplied by the voltage across each switch. So here we have the supply VDC by 2 given for each switch. So VDC by 2 multiplied by the modulating signal will give us Vmax. So that's 0.8 into 250. 0.8 into 250 is 200 volts. So we have 200 volts as Vmax. The next thing we need to find is ZL. Now the impedance of the load can be written in terms of R and L, finding the resultant. So ZL is the resultant of the resistor and the inductor. So solving this, we get root of 12 square plus 16 square, which is 20. So we have ZL as 20, Vmax as 200. Let's substitute into the load current. 200 divided by 20, and that's 10 amps. So the final answer here is 10 amps. I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.